Hi, so I'll be presenting my lab on oscillations. So I'll go over the lab basics like the objectives, the physics principles, the formulas, and I'll go over the models of the code and versus experiment, and then I'll answer the what does it mean question. So the objective of the lab is to observe the motion of a spring mass system where the mass swings in an arc as it oscillates on a spring. So I used Newton's second law and the momentum principle, where I incorporated the velocity update and the position update formulas in my code, and then the F net is equal to F spring plus F graph, as shown on this diagram, when like the spring is like stretched. And for the energy principle, the system is the mass, the spring, and the earth. So the delta E is going to be equal to 0 because it's equal to work, which there's no work in this case. So it's equal to the delta K, which is the kinetic energy calculated through this formula, the spring potential energy calculated through the formulas as shown here, where this K is the spring constant and this S is from the length minus the relaxed length, and the change in the gravitational potential energy, which is mgy. And so for the code, I got the initialization values stuff from the pre-lecture video, and I also used the equations mentioned in the previous slide. And so this is my code. Like I used the values like the mass from the video, and like the spring constant, the relaxed length, and then I updated like the L and the L hat and then the S for these calculations for the energy, for the kinetic energy, gravitation, spring, and the total energy. And then in the loop here, I calculated for the F net and updated the velocity and the position using the momentum principle, updated the spring, and then calculated the energy change. So these are the graphs I get when I run the code. And as for the tracker, I used a pre-recorded video and I set up the calibration stick and the axes, and this is what it looked like as I tracked its actions or its motion. And so what happened is that like the experimental graph is a bit off due to human error, like as shown here. It didn't really match exactly with the model's graphs or the trend, but it does like obey the general trend. And so what like caused this difference could be due to like mistakes in like the value, like the experimental data that like caused the spring constant K to deviate, because the K is calculated using T, which could differ a little bit using the experimental video. And for the T versus Y graph, I could have possibly over-predicted the initial displacement, which affects the amplitude for the graph. And so like to fix that, like try to redo my T and then recalculate my K, and also like try to get the correct initial displacement by redoing the tracker data. And for the what does it mean? So my model system does obey the energy principle because change in E is equal to change in kinetic plus the spring potential and the gravitational potential all equal to 0. So this delta E remains 0 throughout, and the U spring versus the U graph, they're pretty much opposites of each other, as you can see here, and the delta K just oscillates due to the changes in the object's velocity. And so for the what does it mean continued, if I were to get two estimates of oscillation periods using X and Y position data, if I found like the time for like the one peak and then like another time after like 5 peaks, I'll get 1.67 seconds for the X position and 1.52 for the Y position. And these values affect the K, which is the spring constant in this like experiment, and that's what possibly caused the experimental trend to kind of deviate a little bit from the model's trend. And that is pretty much it. Thank you.